Hello everyone, this is Tom Bishop from Winland Institute. I'm going to demonstrate some of the Character Description Language, or CDL features of Winland 4.0. Winland provides the ability to list all the characters with a given stroke count. Here I'll list all the characters with 15 strokes. This is a good illustration of the CDL database. The database serves as a font. The description that is used to display a character is the same description that tells us how many strokes are in the character. That guarantees consistency. If I click on one of these characters and I display it in the stroking box, we can be certain that it really will have exactly 15 strokes. The description gives us not only the stroke count, but also the stroke types. CDL distinguishes about 40 different stroke types, which are divided into 5 standard stroke categories. Here you can see that this list is organized by the strokes. First, all the characters that start with 2 horizontal strokes, then all the characters that start with a horizontal and a vertical, and so forth. As we scroll down, we can see that there are a lot of characters that have 15 strokes. This is not an ordinary font, it's all CDL. The characters you see here are all being written one stroke at a time, but you can't see that since the speed is almost instantaneous. One of the problems with ordinary Chinese, Japanese, and Korean fonts is their size, especially if you want to download them or use them on a mobile device. The complete CDL font is stored in compressed form. It is only 1.3 megabytes for about 80,000 characters. That's about 16 bytes per character, much smaller than an ordinary font. Our CDL font database not only enables us to display and organize characters, the exact same information also enables handwriting recognition. Now I'll open a new window and show you how the handwriting recognition works. I'll write a character here. Winland will search all the characters that have the same stroke count and find whichever one is most similar to this one based on the coordinates. There, it recognized it correctly. I'll write another one. You can see it correctly recognized these 2 characters. Now let's look at one of these characters in the stroking box. There are a number of ways that you can modify the appearance. For example, we can change to a plain style, like this. We can change the thickness of the strokes. We can also change the thickness in this style. So effectively, in a single CDL font, we really have a collection of fonts, all for the price of one. Let's look at the actual CDL description in its XML format. We have 2 comp elements. Comp stands for component. This is the most common situation, that a character will be described as a combination of 2 components. This component is an exception to that rule. If we look at its description, we'll see that it includes stroke elements as well as comp elements. The description of this character here refers to the description of this character. Now, it would be possible to describe this character, or any character, purely in terms of strokes, using only stroke elements. In fact, we have a method for automatically reducing any description to one that uses only strokes. But by doing it this way with comp elements, we first of all save some time. We don't have to repeat the details about this character when we've already described it here. Also, the use of components makes the database much smaller than if we described each character separately in terms of its strokes. Perhaps more important, this method ensures consistency so that the stroke order of this component, implied by this description, is guaranteed to agree with the order given here. Furthermore, the relationships between characters and components are important for many applications, and this has been recognized for thousands of years. For example, we can list all the characters that contain this component. Applications such as optical character recognition should take these relationships into account to achieve the highest possible accuracy, but currently they do not. I mentioned the problem that ordinary Chinese, Japanese, and Korean fonts are large in terms of memory and bandwidth. Another is that they're always incomplete, and adding new characters is difficult. Thousands of new characters keep being added to Unicode every few years. CDL enables full Unicode CJK coverage, and adding new characters is quick and easy. Now I'll show how to create a new description. I'm going to create a new character that contains both of these characters as components. We can move the components around like this. Let's also add a stroke element. I'll add a stroke of type D for DN, which means dot. And I'll put in some arbitrary coordinates here. And then I'll modify them using the graphical interface. I'll move this stroke right on top of here. That looks pretty good. Now this description we've created is not associated with any Unicode code point because we just made it up. It's still possible to put this character into a text. Now you see we've put this character in here, and we could put this text into an email message and send it to somebody. And if the recipient of the message has a copy of Winlean, then they'll be able to read it, even though the character is not in Unicode. If we reveal codes, we see that what is actually contained in here is simply the XML. But normally that can be transparent to the user. And it looks just like another character. We can change the size. We can change to a different font style. And the character will match. If we want to, we can associate this description with a Unicode code point. A suitable choice for that would be a private use code point. I'm going to save it at EE00. And now, if we list characters by Unicode, we see there it is. I'm going to regenerate the stroke index quickly. And now I can use the brush tool to write this new character. And there it is. Users of Asian languages on computers are no longer limited to the characters in any particular font. For the first time in history, the creative power of the ancient writing brush is combined with computer technology, not only for graphic image of writing, but for true electronic text.